So this lab is about the effect of air resistance on gravity on a falling object starting at rest. So to do so, to study that effect, I went out, took some video. I took a video of a ball falling. There, you can see the ball falling. And I took video of a bumper sticker magnet type thing falling, so there's more air resistance there. So the lacrosse ball was my heavy object, and this bumper sticker magnet thing was my lighter object. What I did was take that data and put it in Tracker. As you can see, got those points out, put that in this spreadsheet, and then I went into VPython, and using the program that we did in lab, I modified the numbers. I found the weight of a lacrosse ball online, and my bumper magnet weighed about as much as a packet of 1 serving of premium hot cocoa from Ghirardelli, and that weighs 24 grams. So I just, I went with 24 grams there as an approximation of the mass, and just changed the initial position vector depending on where it started out. And I ran that and extrapolated that data to this spreadsheet here, as you can see. This data here is the data for the lacrosse ball falling, the actual data that happened, and this is the simulation, and this is the magnet, the actual magnet, and this is the simulation. And so I graphed those over here, and as you can see, the ball falling was very close to the simulation. There were a couple where it's below or above, so maybe I clicked somewhere poorly on Tracker or something like that, but otherwise it was very close. And eventually the blue one is the real, the red is the simulated, so the blue one ends up a little higher at the end. Blue one's a little higher normally, right? There's just this one's kind of off, but blue is normally a little higher, and that's because air resistance was not included in that simulation. It was just gravity. And with the magnet, which was flat, so you have more air resistance, you can see that the actual position of the magnet is higher than the simulated position, because the simulated position only included the gravity. I went in to VPython and changed the drag down with the constant of proportionality here to get so that the ending positions were the same for both the model and the actual data. So I did that for the lacrosse ball, and that's this here. That's the model, the updated model with 0.018 as my drag coefficient, and the magnet, this is the data there, with 0.0245 for the drag coefficient. So as you can see, the drag coefficient for the magnet is much higher. It's almost, well, it's 0.005-ish, 5.6-ish higher, which is pretty significant. You look at this the actual magnet one is the blue, and the simulation is the red. So what happens is the red is this smooth curve, and the blue one, you can see how the position is higher for a while, and then it drops down and then matches the simulation at the end here. And that's because if you look at the video again of the magnet, you'll see that it turns right when I drop it there. So how it turns. So that decreases the air resistance here-ish. The ball is much better. The blue here is the actual data, and the red is the simulated data. And it looks like that the actual data and the simulated data line up fairly well throughout most of it. Again, I think these two here, there were maybe some issues with where I clicked on Tracker. It was really hard to tell where things were because it was all blurry. Maybe this could be construed as getting flatter, but I'm not sure that that's quite flat yet. But these 4 points here look like that's a terminal velocity there. Again, it's kind of hard to tell without more data. And with and without drag, so this is the with drag, this is the without drag. This one you kind of can see that a little more, that flattening out, than you can here. But again, it's kind of hard to tell exactly where that would be. But yeah, you can definitely see there's starting a trend towards that terminal velocity there, and it looks like that is something you could probably pull out from the data, if you ran it for maybe like a full second instead of just 0.4 seconds. So what if For the what if question, the object that drops slowly would reach terminal velocity faster because you'd start at a higher velocity to begin with, and so you'd reach that terminal velocity due to the acceleration due to gravity more quickly. If you go into that and do maybe 5 seconds, you start to see here that is definitely a straight line, and that's definitely going straight as compared to this curve here. And that's with the air resistance, right? You take away that air resistance, and when you run that, you don't get that straight line, as you still see the curve. The curve goes all the way, and you don't get that straight line at the end there. So that's what would happen if you gave it an initial velocity, if you're dropping it from rest, if you don't give it that initial velocity. So that's fine, and that's what I got. So thanks, bye.